I'm working on a project to detect the introduction portion of Dragon Ball Z Kai episodes because I wanted to replace replace the audio segment in each of the episodes with um, the audio from a specific singer singing the intro, because that's what I remember um, when I was watching it as a kid. So the way I would do the replacement is I would have FFmpeg do the actual replacement on the video, seeing as though I already have the episodes downloaded. This is just a small subset of those. But yeah, I would need FFmpeg for the, and I would also need the start position of the intro in each of the different episodes. And that intro can change where it is depending on what episode it is, and also if there's going to be a recap of the previous episode or episodes or not. So I need a method to reliably find the start of the intro. So the way I'm doing that is I tried a few different ways. The first was based off of the first frame in the intro, but the problem with that is the intro for this show starts off with a few black frames, and that'll go on for like around a second, maybe a little bit less. But so if I was to use that and do the actual audio replacement with just the raw timing, I would have an offset audio clip relative to the video of the intro, and that's not what I want. The other method I used is last frame based intro detection, which is basically I have a known last frame of the intro, which is this, and I'm going to be using this and each frame in the episode to compare it with this image using MS-SSIM, which is multi-scale structural similarity, and that will give me a number basically saying how similar are these two images. And basically if it's above a certain threshold, it's the same frame. Now, because this frame will be on screen for more than one frame, I want to see where the drop off is. So right after the frame I just showed you, it's going to go into the actual content of the episode. So it's going to drop from a very high similarity from this like line of images down to something not so similar. So for this method, I'm just calculating where this drop off is, this negative drop off. And that is basically a tell that says, hey, this is the end of the intro. And then using the FPS and length, actually realistically only like the length of the intro, I can backtrack it a certain amount of frames and say, okay, this is the start point of the intro. And having the duration, I can just pass that to FFmpeg and it'll do the audio replacement. So the way I did, I'm just going to be focusing on the last frame today, and I'm going to go over my naive multi-core version. Essentially, what I do is I am hoping to get a batch of 1,000 frames, push them to a queue, and then have a number of consumer processes consume those frames, add them to an array called scores, basically the scores that they calculate, and then at the end of that batch, I go through and say, hey, is the difference between the previous and the current greater than 0.5? This is a realistically, this threshold can be tuned. I didn't set it to something like, oh, if essentially this can be tuned. I'm not sure if this is the perfect value for it, but for now, that's what that works. And it'll give me a timestamp and the end frame, stuff like that. But yeah, so this main process, what it does, it gets frames to count, which right now is 1,000, and reads those values, converts it to black and white, and then converts it down to the shape of the downscaled version of itself to a different resolution. Right now, the reference image is I think this is a 720p image, but the video stream is in 1080, and that helps to reduce the calculation time because the structural similarity, it operates faster on smaller images because it's computing statistics on blocks of the image. But yeah, after converting it to grayscale and then shrinking it, I put it onto a queue, and once that's done, I start up the consumer processes. And the consumer processes, they just pop images off of the so they pop images off of the queue. It'll get an index for which frame it is, and then the actual image, and then I can pass that to this function, which I get from this scikit-image library, and then I can put the calculated index at the index of the frame that I get from the queue. And then each process is going to do a number of these, and once that is done, I loop through the scores. If I didn't find that drop off in that batch, it resets, I grab another 1,000, do it all over again. So that's the process, and it works. Nice. So this will take around like a minute to run. You can see the performance statistics in the blog post, which I'll have linked below, but I'm running a Ryzen 7 5800X3D, and I'm using 4 cores, and I don't get the performance I want, and this is something I'm going to be working on in the next iteration of this project, but the single core performance I got was right here. So it did this many frames in 1:22, which gave me this FPS. The average FPS overall for the multi-core implementation was higher, but then per core it was a lot lower, almost a little less than a third, I think. And I suspect that has something to do with, okay, so yeah, this is intro and timestamp is at 151, which with a intro of like 1:26 means that this happens at like frame 20 or second 25 seconds in ish. But what was I just saying? Oh, I suspect the slowdown comes from me using this multiprocessing queue. I think there is built-in locking and like synchronization between the processes. Realistically, what I could do is just have like a lock-free algorithm where each core does a certain boundary of frames, and then I wouldn't need to worry about, oh, let me just pull off the first n images or whatever. And that would also probably help because I could have like a shared memory thing. Like in each consumer class, I could say, hey, copy this amount of images, and that would probably just be the frames to count divided by the number of processes there are. It would copy that amount locally from that global queue, operate on them, and then that would probably be faster. Because I think right now the fact that a consumer class, or the time it takes to process or pull off an image from the queue, process it, and then give me a score, is a lot less than the time it takes to, or it's the time it takes to pop off a process is around 5 times the time it takes for an image to be pushed on. And if I'm using any more than 4 processes, that's gonna cause starvation. So to avoid that, I want to just pre-calculate everything, which is what I'm doing here, and then having these guys, these consumer processes, grab off the queue. But if I don't need a queue, I can just do it based off of index and boundaries and not have any synchronization overhead, and I think that would make it faster. I'm not sure if it's gonna improve this FPS by 4. I would like it to be, but won't know. Another issue that I found was around the intro visuals also change throughout the series, not just the singers. So I'm going to need a better method to detect that change. I'm thinking of doing a audio-based approach, but I'm not sure how that would go with different singers. I know Plex does have audio-based intro detection. Not sure how well that goes, but yeah, that's something I could explore. But yeah, if you want to read about this in a little bit more detail, and if you want to see the code, I'll have a link to it in the blog post, and I'll have it below as well. You can read it without me saying and in your face. But yeah,